All right, good morning. We're going to do slope today. This is section 2.3. I will basically go through the notes, and then I'm going to even work out the problems at the end. But when it gets to working out the problems, then you should pause it and try and work it out yourself, and then look and see what I did and compare the answers. All right, so the slope of a line measures the steepness of a line. We're talking about, like just like a hill, how difficult would it be to walk up it or something like that. And this is done by doing rise over run. How much do you rise divided by how far do you run? So how much do you go vertically in the space that you also move horizontally? This is also a lot of times written as change in y over change in x. That little triangle is the Greek letter delta, and it means change in whenever you see it in front of a letter. What it basically means is final minus initial, or 2 minus 1. So delta y would be y2 minus y1, and delta x would be x2 minus x1. And if you do that, this will give you a number that tells you how steep it is. The larger the number, the steeper it is. Positive numbers are basically going to tell you that if you're moving left from right, you are going uphill, right? And negative numbers, so that's a positive slope. And negative numbers are telling you if you're moving left to right, you're going downhill. Those are negative slopes. Okay, so let's try a few here. I'll do the first couple and then start trying to pause and see if you can do them after I do it. But we basically pick a point 1 and pick a point 2. I'm going to call this point 1, this point 2. That makes this x1, this y1, this x2, and this y2. And so to do the slope, I do change in y over change in x, or rise over run. So it'll be y2, which is a 4, minus y1, which is a negative 1, divided by x2, which is negative 2, minus x1, which is negative 3. So subtracting a negative becomes plus a positive. Same thing in the denominator. And so we end up with 4 plus 1, that's a 5, divided by a negative 2 plus 3, that's a 1, and so this equals 5. And if you look at this, this is the rise, 5, this is the run, 1. So every time you move up 5, you're going to move to the right 1, okay? Up being positive, right being negative. So if you think you got it, pause it before I do the next one and give it a try. Otherwise, I'm going to get started on it. x1, y1, x2, y2. Slope is negative 2 minus 4 over 2 minus negative 3. And so negative 2 minus 4 is negative 6. Over 2 minus negative 3 becomes plus positive 3. And so 2 plus 3 is 5. So this is a negative 6/5. That means this is actually a falling slope, where if you're moving left to right, you'd be going downhill. And what that means is instead of your rise would be negative 6, so you basically would fall 6, and then you would move in the positive direction 5. So you're going to rise, this is your rise, but you're basically going to fall 6 because it's negative, and this is your run. Okay? Now the next one, try another one here. This is x1, y1, x2, y2. And so slope is going to be 3 minus 3, that's y2 minus y1, over x2, which is 4, minus negative 2. And so if you look at this, the very first thing that happens is you have 3 minus 3 on the top, that's a 0, over 4 minus negative 2 is 4 plus 2 over 6. And anything that you have a 0 over top of, so 0 divided by anything, is just going to be 0. And what this is telling you is that we have a slope of 0. We are not rising. The rise is 0. There's no rise. We're not moving in the y direction at all. And so then it really doesn't matter what the run happens to be. It's going to be 0. And so basically that tells you this is a horizontal line. There's only changes in the x direction. This is horizontal. Okay? There's no vertical shifts at all. So now let's take a look at this next one. x1, y1, x2, y2. And the slope's going to be y2 minus y1 over x2 minus x1. And so we'll get -4 minus 3, that's a -7. Over top of 2 minus 2, that's a 0. So here we have a rise of -7, or a fall of -7. We're going down. But then we have no run at all. We're not moving in the x direction at all. That means this is a vertical line. We're only moving in that y direction. We only have a rise. We don't have a run, or a fall, I guess, because it's negative. But this is vertical. And since we can't divide by 0, that makes this slope undefined. Okay? And so down here at the bottom, you see a few examples of positive slopes, negative slopes, 0 slopes, and undefined slopes. Make sure you're very good at recognizing each of those situations, so that, especially if it's slopes of 0 or undefined, you're not mixing those up, and that you're not mixing up positive slopes with negative slopes and things like that. So make sure you have those pretty well understood. All right, on the next page, we're going to talk about a couple different forms that we can put our equation in for just straight lines. The first one is the point slope form, and it's going to look something like this. Okay, and essentially what you're going to do is you have a slope m, and then you're going to have a point, and you're going to plug in the values of those points. You're going to plug them in there and there. Okay, you're going to plug in whatever point you have. You plug them in there, and then you plug in the slope as well, and that would be it. So if you were given the slope and you were given the point, you can immediately put it into this form and do that. All right, where m is your slope and x1 comma y1 is your point. That's a point, any point on the line. Next, if you take that form and you solve it for y, so we can move over by solving for y, we can actually get a new form called the slope-intercept form, and it will look like this: y equals m times x plus b. And m is still the slope, but b is going to be your y-intercept. All right, and so that's a nice little form that you can get it in as well. It's also a form you can go to directly. If you have a slope and a point, you just have to do a little bit of algebra. You have to plug the point in and solve for what you have to basically plug in x is 0 and solve for what the y-intercept is after you get the slope in, and it can be a little more time consuming, but it can be pretty much gone to fairly directly as well. All right, so let's try these examples here. The line with a slope of 4 and passing through that point. So we know that this is m, and we know that this is our point. So we go to our point slope form, and then we're going to want to go ahead and write that down. It's pretty much just writing it, y minus y, so that's y1, that's y minus 2, and then that's going to equal the slope 4 times x minus -1. Okay? And so we can just kind of pretty this up a little bit. Y minus 2 equals 4 times x plus 1. And so that would be our point slope form. Point slope right there. We can continue on to actually go ahead and put this into y-intercept form by simply solving for y. So I'm going to do that. I'm going to add 2 to both sides, plus 2 plus 2. And so that'll give me y equals 4 times x plus 1 plus 2. And so if I distribute this, I will get y equals 4x plus 4. So I multiply that 4 through, plus 2. And then I just combine the like terms. Y equals 4x plus 6. And this is our slope-intercept form. Okay, so we have our two forms there. All right, so let's try this next one. The line with slope of 0, or sorry, of -3, and passing through the point 4, -2. All right, so this is our point, and then we're just going to go through and put this into the proper form. So we're going to do y minus -2 equals m, which is -3, times x minus 4. Okay? And then we can just kind of distribute this. This is minus a negative, so it's y plus 2 equals -3 times x minus 4. And this is our point slope form. Now to get the y-intercept form, I'm simply going to solve this for y. I'm going to subtract 2 from both sides, so a -2 and a -2. And that'll give me y equals -3 times x minus 4 minus 2. And then I'm going to distribute that -3 through, so -3x, -3 times -4 is plus 12 minus 2. And so I'll get a y equals -3x plus 10. -12 minus 2 is, or I'm sorry, positive 12 minus 2 is 10. And this is our slope-intercept form. All right, let's try one more. Here, we're not given the slope, but we're given 2 points, which means we can actually figure out what the slope is. If we call this point 1 and this point 2, this would be x1, y1, x2, y2. And then we can find the slope. M is going to equal change in y, so y2 minus y1, that's 5 minus -10 over top of x2 minus x1, that's -1 minus -4. And so that'll give us a slope. 5 minus -10 is 5 plus 10, and -1 minus -4 is -1 plus 4. So 5 plus 10 is 15. And then -1 plus 4 is 3, and that'll give us a slope of 15 divided by 3 is 5. So now we have our slope. And then you might be wondering, well, which of these 2 points do we pick to actually solve this? And so we're going to try each one. So let's start with the first one. We'll do y minus y1, which is the -10. All right, so I'm picking the left point, the first one, and then I'm going to do the slope times x minus x1. Okay, and so this will become y plus 10, and then this will be x, it's going to be a plus 4, and I'm going to go ahead and distribute here. So it'll be 5x, and then here I have a plus 4, so it'll be plus 20. And then I just need to subtract 10 from both sides, and I'll get y equals 5x. 20 minus 10 is 10. And so that will be my my y-intercept form. But if I come over here and I try this again, but this time I'm going to do it with the other point. And so what I'll have is I'll do it with point 2, is I'm going to have y minus, this time it's the y2, but it's y minus 5 equals 5 for the slope, and then x minus -1. Okay, that's the second point. And so if I start fixing this up, I'll have y minus 5. Here I have minus -1, so I'll make that plus, and then I'm going to go ahead and distribute, so it's 5x plus 5. And then it's going to be y equals, I'm going to add that 5 to both sides, and I'll have 5x plus 10. And so I ended up with the same answer either way that I did it, and so it doesn't really matter which point you pick. In fact, you can pick any point that lies on the line, and it'll give you the same result. Okay, so take your time looking at it again, and let's try some more over here. I might start speeding these up a little bit so you can start doing these kind of on your own, pause them and get a little faster. And so for this one, we have a line passing through the point 3, 4, and 4, 4. And so again, we're going to have to find the slope. M is going to equal, and we're going to have y minus y, that's 4 minus 4 this time, over 4 minus 3. So I picked this as 0.2 and this is 0.1. And so 4 minus 4 is 0, 4 minus 3 is 1, but this equals 0, which means we have a slope of 0. So if we do the point slope form, right, we're going to end up with y, just pick either point, I'll pick 0.1, y minus 4 equals 0 times x minus 3. Okay? And if you do that, and you distribute, this whole right side becomes 0, and you end up with y minus 4 equals 0. And so then if you solve for y, you get y equals 4 by adding 4 to both sides, and this is your slope-intercept form. And hopefully you note that this is y equals 4, this is a horizontal line, which fits with the slope of 0, right? So this is a horizontal line, which is what we said earlier occurred with a slope of 0. So we've got that. All right, so let's try this next one. We've got another line passing through these 2 points. So let's do the slope. I'm going to call that 0.1, that 0.2. So it's going to be 4 minus 3. Oh, I'm sorry, negative 4 minus 3 over 2 minus 2, which gives us a 0 in the denominator and negative 7 on the top. This is undefined. All right, we have an undefined slope here. So since this is undefined, essentially we just have to have a vertical line that passes through, it basically just passes through these 2 points, or really any point. And since you notice they both have the same value of x, that's going to just give us that x has to equal 2. Because if we look at our graph and we do the point 2, 3, that's right here. And if we do the point 2, 1, 2, negative 4, that's over here. And so any point on here, any point where we have an x value of 2 is going to be on this vertical line. I missed that one a little bit. I'll make my points a little bigger so it overlaps. Okay? And so that's what we get, and that's what we have to have there. We have no slope, or we have an undefined slope, and therefore it's a vertical line, and it's going to pass through the x points of your points. So really you only need 1 point if you know it's a vertical line, because it'll just pass through or be a vertical line at whatever that point is. So like here, the line with an undefined slope and passing through the point 3,5. This is undefined, therefore it's vertical, which means it's an x equals something, and it has to be x equals 3 because it's going through there. So this is a vertical line because it's an undefined slope, and it has to be x equals 3 this time because it's going through the point 3,5. It's going through the point 3,5 and 3,6 and 3,7 and 3,1 and 3,0 and 3 negative 100. Everything it's going through has an x equals to 3. All right, here, now we have a line with a slope of 0. All right, remember what that slope of 0 means. This is going to be a horizontal line. Okay, and it's going through the point 4, negative 2. Well, horizontal lines, they have one constant value of y, which in this case, we're just going to pick that out, is negative 2. Because everywhere along that line, we have to have a y value of negative 2 in order for it to be this horizontal line. And so the x value can basically be anything that you want that's on that line. Okay? So let's take a look at the next page. We're going to do some graphing here. So this is mostly going to be picking out here, at least at the beginning, picking out y-intercepts, picking out a slope, and doing it. So if we look at this, the b is going to equal -3, and that's your y-intercept. M is going to be 2, so I got the -3 from right here with the minus sign, and I got the 2 from right there. So we go to -3 as our y-intercept, that's right there. And then we have to have a slope of 2. Well, 2 equals 2 over 1, which means we have a rise of 2 and a run of 1. So what we'll do is we'll start right here, we'll go up 2, 1, 2, and then run over 1. And in fact, you can keep doing that, up 2 over 1, up 2 over 1, just like that. Plot out a few points, and then connect them in a straight line. Okay, there you go. There's that one. So now let's look at this one. Here, we're going to have b is going to be 4. That's that 4 right there. That's your y-intercept. And then your slope here is -2/3. So m is -2/3. So we go to the point 0, 4 here for our y-intercept. So 1, 2, 3, 4, right there. And then we have a rise of -2, so that's a fall of 2, and a run of 3. All right, so that means we can go down 2 and then run 3 to right there. Down 2, run 3, right there. Okay, notice this keeps us on a straight line. Also note that -2/3 is equal to 2 over -3, which means we could do a rise of 2 rather than a fall, and then move left 3. Our run would be left in the negative direction. And that will still keep us on the same line. In fact, I'll do it here in red, and I'll do a rise of 2, 1, 2, and a leftward run, a negative run of 3. And notice that still keeps me on that same line. So at this point, we just draw in our straight line through the points, and there we go. We've done the graph. All right, so for this one, we actually have to solve it for y first. We need to put it into that y-intercept form, slope-intercept form. And so what we'll do first is we'll subtract 2x from both sides, and that'll give us -4y equals -2x minus 12. Okay? And then we'll divide by -4. Get -2 over -4x, and we'll get minus 12 over -4, like that. Okay? And then canceling out your negatives, this is negative over negative, that's a positive, it's 2 over 4, it's a 1/2 x, so negative over negative becomes positive. Over here we have minus 12 over 4, so that cancels with that. We end up with a we end up with a plus 12 divided by 4 is 3. And so once we do that, we're going to have a slope of 1/2 and a y-intercept of 3. So b is going to equal 3. That's your y-intercept. And the slope is going to equal 1/2. So we'll go to 0, 3. There's our y-intercept. We'll do a rise of 1 and a run of 2. So rise 1, run 2, just like that. Get a couple points in there, draw in your straight line. Okay? So there are those ones. Let's go on over here to the next page. I'll go ahead and finish these up just so you make sure that you actually have them. So for this one, again, we're going to have to solve for y. So we're going to add 3x to both sides, okay, to cancel it out. And we'll get 3y equals 3x plus 3. And if we then divide everything by 3, we'll get a y equals x plus 1. So in this case, we're going to have a y-intercept equal to 1, and we're going to have a slope equal to 1, which is just going to also be 1 over 1. So we'll have a rise of 1 and then a run of 1. And so if we go to x equals 1, that's right there, And then we just have to go up 1 over 1, up 1 over 1, up 1 over 1. And then the same thing, this also technically equals -1 over -1, so we could go down 1, left 1, down 1, left 1, like that. Down 1, left 1, and all these are on the same straight line, so we just draw in that straight line, and we've got it graphed. Now you typically don't have to do as many points as I'm doing, I'm just showing you different ways to get the points. So here we have x equals 3. So if we look at that, this is a point where every point on this line, x is equal to 3. In other words, it's like this, 3 and then any y you want to pick. So you can pick any y that you want. You can pick 3, 0, let's say. That's one right there, 3, 0. You could pick 3, 5, 1, 2, 3, 4, 5. Anything you pick where x is 3, you can pick any other y you want. 3, -2. Notice they're all going to be right on top of each other. This is just a vertical line, just like we saw before. So when we graph it, it's a vertical line. 3 and then anything else is going to work there. So this is just a vertical line at x equals 3. All right, now let's look at this last one. This one is y equals -4. Now for this one, we can have any x value we want, but y has to be -4. So again, if you're not sure, you're forgetting, oh, is this a horizontal line or a vertical line, just do something like this and go look at it. We can go anything we want negative with anything we want out front and then a -4 for the second number. So we come down here, we can go 0, -4. How about 7, -4? 1, 2, 3, 4, 5, 6, 7, -4. There, that's right there. -4, -4. Right? All of these are going to end up all horizontal with each other. Draw that line in. There you go. You've got it. This is a horizontal line. It's going to have a slope of 0 with a slope equal to 0. And if you think about this, you could even rewrite this y equals -4. You could even rewrite this as y equals 0 times x minus 4. And then that would be m0, and this would be the y-intercept, -4. Okay? But no matter what, horizontal for y equals, the vertical for x equals. So if y just equals some number, horizontal line. If x just equals some number and there's no other variables, vertical line. Okay? So that's pretty much it. I hope this helps, and be sure to do your homework and try practicing these. If anything's unclear, try rewatching the video, listening to it again, and if it still doesn't help, then we can talk about it in the next class. Just be sure to let me know. All right, thanks.